Good day everyone, welcome to today's video. Make sure you hit the like button and subscribe to this channel to get more of these videos. So we'll be looking at an example under the last video, which is the simple and compound microscope. So in this example, okay, you can feel free pause the video and try it. An object of 0.2 meter high, so we are given the object height. So object height, which is 0.2 meters, is placed 3 centimeters from the objective length. So we have the object distance to be 3 centimeters of a compound microscope. So we are dealing with a compound microscope having focal length 2 centimeters and 5 centimeters. So for the objective length is 2 centimeters, and for the eyepiece length is 5 centimeters. So calculate the distance between the lenses when the microscope is in normal use. So the distance, if you look from the last diagram, the distance between the microscope is, we have something like this. We have 2 lenses. Now the distance between the 2 lenses is this. So how do you get the distance between the 2 lenses? Now when we have the object, it falls here, it produces an image this way. Now the image here serves as the image produced serves as the object distance for this. We have something like this. Now if you look at the distance between them, if I know from here to here, if I can get the distance from here to here and the distance from here to here, I will know the distance between the 2 lenses. So what is the distance between here and here? If you look, this is the image. H1 is the image produced by the objective lens, and the image produced here. So the distance from here to here is the distance, that is V0. Then from here to here, same image that is produced now serves as object to the eyepiece lens. So that means the object distance of the eyepiece, give me this. So that means the distance between the 2 lenses is V0 and UE. So let's calculate V0, VO and UE. So how do we get VO? Since we have our focal length and object distance, we can use the lens formula that says 1 over F0 FO is equals to 1 over VO plus 1 over UO. So you can see from this diagram, you can see that the image produced is real and our focal length is a converging lens, which makes everything to be positive. So what we want to calculate is VO. So 1 over VO is now equal to 1 over FO minus 1 over UO, which is 1 over FO, which is 5 centimeters, 5, minus 1 over U, which is 3, 1 over 3. So we have 1 over VO is now equal to, our F is 2. So this is 2. So LCN is 6. Then we have 3 minus 1. So 1 over, let me continue here. So 1 over V is equals to, so 3 minus 2, that's 2 over 6. So if we do this, our VO will be equal to 3 centimeters. Okay. Nope. Sorry. This should be 2. Then this should be 1. So our VO is now 6 centimeters. Now to get UE, the same thing. So this is for the objective. That's for the objective lens. Now for the eyepiece lens, we are given, we are only given this. But if you look at this now, remember we said the eyepiece under normal adjustment, we are told that what to use when in normal use. That is when the microscope is not adjusted. Now when the microscope is not adjusted, we have our V. The VE will be equals to D, which is equal to 25 centimeters. So using the mirror, the lens formula, 1 over FE is equals to 1 over VE plus 1 over UE. But the image, look at the image produced by this lens. Look at, this is where the object is, and look at where the image is. They are on the same side. So definitely it is virtual. So this is negative. So we have 1 over 5 is equals to minus 1 over 25 plus 1 over UE. So 1 over UE is equals to 1 over 5 plus 1 over 25. So we have 25, then this will be 5 plus 1. So we have UE equals to 25 over 6. So this will be approximately 4.2 centimeters. So the distance between the lens will now be equals to VO plus UE, which is equals to 6 centimeters plus 4.2 centimeters. So this is equals to 10.2 centimeters. So that's the distance between the two lenses. Now for the second question, it says the angular magnification in this adjustment. Now, since the angular magnification is equal to the final image over the object height, but this we don't know the height of the final image, so we can't use this. So the best way to do this is to use M, which is equal to minus D over FE plus 1 into VO over FE minus 1. So we have minus D, which is the distance, that is 25, over FE, focal length, that's 5 plus 1 into VO, which is 6 over FO, which is 2 minus 1. So we have minus this is 5 plus 1, that's 6 times 2, you see that's 3 minus 1, 2. So this is minus 12. Now the negative. The negative shows that the image produced is magnified and it is virtual. So the image produced is virtual. Then next, we have to calculate the height of the final image. Now, we know that angular magnification is equals to height of the final image over height of the object. We've already calculated this to be equals to 12. Then, for the final image over h, we are given h from the question that an object of 0.2 meters high. So 0.2. So h2 is equals to 12 times 0.2, which is 2.4 meters. So that's the height of the object. Then the fourth question says the angular magnification if the microscope is not in normal adjustment. If it's not, now when it is not in normal adjustment, the image will be formed at infinity. Now remember, under simple microscope, when image is formed at infinity, the magnification is equals to d over f. So this formula will then transform to m will now be equals to d over fe into dv over f naught minus 1. So where this is for the eyepiece and the image form is at infinity. So that's 25 over 5 times this. What do we have here? That's 2. So we have 5 times 2, which equals to 10. So when not in normal adjustment, the magnification is just 10. So that's it for this video. So make sure you like, hit the like button and subscribe to this channel to get more from it.